Assalamu alaikum students, welcome back to the online classes again. My name is Sir Aoun Ali. I am your maths teacher, and today in our online class we will start chapter number 4, whose name is algebraic manipulation and algebraic algebraic expressions and algebraic formulas. So now the syllabus, as you know, has been reduced, and we will follow ALP syllabus in chapter number 4 as well. So in the exercise 4.1, I have marked these questions of smart syllabus, and I want all of you to mark these questions. 4.1, question number 1, second and fourth part. Question number 2, first and third. Question number 3, first, third, sixth. Question number 4, it's B part. And then question number 6, first, third and fifth part. Now let's start this exercise, and first we will mark the definitions of this chapter as usual. So the first definition is of algebraic expression. The definition start from this: when operations of addition and subtractions are applied to algebraic terms, we obtain an algebraic expression. When operations of addition and subtractions are applied to algebraic terms, we know that algebraic expression, the definition is, see the definition again, when operations of addition and subtraction are applied to algebraic terms. We know that in algebra we deal with variables, their coefficient, their power, plus another variable coefficient, another variable, another square, minus say some constant also. So when the operation of addition, subtractions are applied, when the operation of definition addition and subtraction are applied to algebraic terms, 3x square is an algebraic term, 7y square is an algebraic term, 8 is a constant, is algebraic terms. We apply the operations of addition and subtraction in these algebraic terms, and thus the result obtained, it is a algebraic expression. There are many algebraic expressions of different kind. 3x square plus 7y square minus 8. You may define 3x cube minus 7x square y plus 6y की 3. Similarly 6x की 5 minus 7y की 2 plus 6z minus 2. They all are algebraic expressions. Because they are algebraic expression, they have the operation of addition and subtraction in algebraic terms, so that's why they are called algebraic expression. The next definition is of polynomials. I want you to mark this definition on your book first, and then I will explain it to you. The definition is: a polynomial in the variable x is an algebraic expression of the form p of x equal an xn plus an minus 1 xn minus 1 plus an minus 2 xn minus 2 plus a1x plus a0, where an not equal to 0, where n is the highest power of x, is a non-negative integer. It means where n is the highest power of x, it means non-negative integer, it is always positive. So from this definition we conclude that all this power of n will be non-negative. It means they should be positive. Where n is the highest power of x is a non-negative integer called the degree of the polynomial, and each coefficient an is a real number. Students, mark this definition of polynomials, and then I explain it to you. See the definition again: a polynomial in the variable x is an algebraic expression of the form p of x equal an xn plus an minus 1 xn minus 1 plus an minus 2 xn minus 2 plus up to so on a plus a1x plus a naught, where an not equal to 0 is where n, the highest power of x, is non-negative integer. So this line is very important in the polynomial, that a polynomial must have a power which is non-negative. It means a polynomial should have power positive. Then it will be polynomial, and if it has a power non-negative, any negative numbers, it will not be a polynomial. Now let me explain you with example. Polynomial is of the form p of x equal an x power n, an minus 1 x power n minus 1 plus an minus 2 x power n minus 2 plus up to so on a1x plus a0, where an not equal to 0. N is highest power, highest degree will be the better word, not highest, degree of polynomials, which is always non-negative. It means if I write n equal to 5 in equation number 1, then my equation will be p of x equal a5 x power 5 plus a5 minus 1 and x power 5 minus 1 plus a5 minus 2 x power 5 minus 2 plus up to so on a1x plus an a0, a5 x5 plus a4 x4 plus a3 x3 plus up to so on a1x plus a0. So it is a kind of expression. You can see all the degrees, all the powers are positive. Now we can write the examples of polynomials. Examples are x power 5, 3x की 5 plus 4x की 4 plus 7x की 2 plus 9x minus 8. It is a polynomial. But when I write 3x की power minus 7, 6x की minus 6, 9x की power minus 5, the degree is negative. For a polynomial it should be non-negative, so this is wrong. It is not a polynomial. Will be a reciprocal equation or whatever so be, but not a polynomial. A polynomial must have a degree non-negative. Here in this case it is given negative, so it is not a polynomial. When the degrees are in positive, it will be polynomial. Now what happens if the variable have power 0? It will retain as polynomial, because any number you have studied in chapter number 2 having power 0 equal to 1, it means the degree of polynomial either should be 0 or should be positive, degree of the variable. But if it is negative, then it will not be a polynomial. I have explained you the definition, and question number 1 is related to that definition. Question number 1, we will solve it on the book. Identify whether the following algebraic expressions are polynomial or not. See that in the definition of polynomial, you have not studied that its power is in rational form or irrational form. In the question number first, 3x square plus 1 by x minus 5. What is this? It means we have to follow the smart syllabus question, but you should know the concept of polynomial. It will be 3x square. Let's write on the register. Question 1. The statement, I am not going to write the statement. Identify whether the following algebraic expressions are polynomial. Reply your answer with yes or no. The first one is 3x square plus 1 by x minus 5. So student, this can be written as 3x square, and this 1 over x, when it will take its reciprocal using laws of exponent, it would be x power minus 1 minus 5. So no. For a polynomial, the power of the variable should be positive, but here in this case it is negative, so this is not a polynomial. We will say in our answer just no. The second part, in the smart syllabus, this question we have to tell either it is a polynomial or not. So 3x cube minus 4x square minus x into square root of x plus 3. If we discuss its power, 3x cube, 3 positive, 2 positive. But here in this case, x and 1 by x, you know that this is x power 1. I am taking this x into square root x in the rough work. This x is power 1 multiplying with the square root sign have a power 1 by 2. Multiplying the same basis, the power will be plus 1 plus 1 by 2. It will be x power 3 by 2. For a polynomial, the degree should be positive integer or 0. But 3 over 2 is not an integer, rather it is a rational number. So number 2 will write on the book is no. This is not a polynomial. And in the third part, x square minus 3x plus square root 2, see the degree of the variable 2 is positive, degree of the variable x is 1, that is positive, and square root 2 is a constant, it doesn't matter. So it will be yes, it is a polynomial. The first one was no, second also no, third is yes, and the fourth one, see that 2x minus 1 and 3x, no doubt it is positive, but when we'll take the reciprocal of 2x minus 1, its power will be negative. So this is also not a polynomial. Now we have finished our discussion on the polynomials and algebraic expression. We will continue this exercise, and today's lesson is only about polynomials and how to identify different polynomials. And I will give you a quiz on your classroom, and you need to just answer yes or no about polynomial. Thank you so much, students. I hope you understand the first online lecture on our Google Classroom. Hope we'll continue the same work and learn these two definitions and know how to what are the polynomials and what are not the polynomials. I will send you a quiz, MCQs based, which you will solve online, and you can view your score as well on the spot. Thank you so much.